And where we are collecting output? Where we are collecting output? We are collecting output across collector, but the radio frequency microwave signal is again passed to the radio frequency output. But the main output we connected is catcher cavity. The output here taking from where? Catcher cavity. This catcher cavity output means again radio frequency signal only it is coming back, but the electrons mood is collecting across the collector. And now next paragraph, what is it? When we are applying DC supply voltage from the figure. From the figure, the DC supply voltage negative is connected to cathode, positive is connected to collector. After applying positive voltage, to this voltage, I have positive as well as negative. Is it positive, negative? Whenever we positive pulses are going, the speed of the electrons will accelerate more. If electrons are accelerating more means what? We are observing bunch of very close bands for the positive half cycle. Whereas for the negative half cycle, far away, gap is there. From the figure, you can observe in the main figure of the cavity crystal there. It is shown very clearly. From this, we can identify which is positive, which is negative accelerating of electrons. Within the drift space, the closer we have, gap between each bunch is very less. So this is for positive electrodes. Whereas for the negative off cycle, here we have gap between a bunch of electrons. So this is deaccelerating of electrons. Wherever it is closer, here field is maximum. Wherever the gap is there, here field is minimum. We will discuss these points. Maximum field and minimum field.
Now, once you collect the catcher only, that some again will pass to the
collector. So, whatever the radio frequency input is given, again that is coming across output, but we are concentrating on the electron bunches, whether it is closer or far away. Movement of electrons is important here. For this movement of electron, I am applying radio frequency input. This radio frequency input is applied to generate electric field. Based on the field only, they are closer or far away. For that. In the second paragraph, what is mentioned? A DC voltage is applied to the collector and catcher. A DC voltage means called the beam or voltage. Here, collector is kept positive based on the diagram. Just check the diagram. Collector is connected to positive. Next, an homogeneous beam of electrons is sending from cathode with the help of heater. With the help of heater, is it? What is the purpose of here for electrodes? Focusing electrode. What is the purpose of focusing electrode? To send it straight, not in diverting directions. Next, all the I am taking the input voltage of the microwave signal. From where we are applying microwave signal? I am applying microwave signal from RF input. What is the wave signal we have? Vi equal to Vs times of sine omega t. What is V here? V is amplitude. Omega is the angular frequency of the wave. Now see the sine wave, whatever we applied. This sine wave consists of both positive as well as negative. This sine wave consists of positive as well as negative. Next paragraph, we will see what is mentioning in the next paragraph. What happening during positive off cycle? What happening during negative off cycle? As the electron passes through the buncher, they experiences a electric field, which this field is proportional to the input signal. This field is proportional to the input signal. And during positive half cycle, what happening? During positive half cycle, there is a more electric field. During negative experiences, it experiences a less electric field. Field is varying for the positive and negative half cycles. Next, when electrons passes through the buncher cavity at 0 voltage, there is no unchanged velocity. What is the meaning of this one? Just see the sine wave. In the sine wave, we have positive, negative also touching to the x-axis. At the time of x-axis, here the velocity is 0. 0 velocity along the axis. Along the axis, velocity is 0. The electron that passes through the buncher gap undergoes an increasing velocity during a positive half cycle, and it get decreasing in velocity during negative half cycle. Positive half cycle velocity increasing, for negative half cycle velocity is decreasing. Therefore, the input signal is speeding the electron flow. during positive and negative half cycles. Thus, an electron passes the Buncher gap. They are facing velocity modulation of the input signal. Velocity modulation of the input signal. In the drift space region, means between the two Buncher cavities. In the drift space region, what happening? The faster electrons will overtake the slower one. Faster one is overtaking the slower one. As the result, electron gradually bunching together. These electrons is coming together. As the electron beam progress further down, the drift space bunching process increases. Means gap ఎక్కువ ఉంది చూడండి. Back side. After this, there is a more gap. Bunching process. Next, we are seeing about density, current, and electromotive force relation. In the next page, it is given. First, we will see the last passage. In the last part is what is explained. EMF, electromotive force. If suppose density is increasing, density increases, current increases, electromotive force decreases. One relation. Density increasing, current increasing. What about EMF? EMF is decreasing. If EMF decreases, electrons are deaccelerating. Electrons are deaccelerating. Second point, if density decreases, current decreases. Density decreases, current decreases. Electromotive force increases. What about electrons acceleration? Electron accelerations is accelerated, increases. That's 2 points is explained in this last paragraph. Electron acceleration is increased, that is explained in this paragraph. Just we know that variation in produced in induced EMF produces effect opposing the current. Density increases. ఏమవుతుంది? Current increasing. EMF opposes the increasing. So EMF decreases and deaccelerate the electrons. Electrons are deaccelerating. Next, if density decreasing, current decreases, EMF will increase, which is accelerate the electrons. Okay, this passage is explained this one. However, many electrons will be deaccelerated and only few are accelerating. Where this point will take place? However, many electrons is deaccelerating. Only few are accelerating. This is after Buncher cavity. Because there is more electrons are deaccelerating, very less is accelerating. This will take place here. See here, what is the point is given? However, many electrons is deaccelerated and only few are accelerated. The deaccelerated electron give up energy while accelerating energy is taking the energy. Thus, it is contributing overall. The velocity of the electrons is modulated. Here, the overall velocity of the electrons is modulated. Above paragraph, what is mentioned in the above paragraph? Where we are keeping this catcher cavity. Wherever the electrons is very closer to each other. In this very less gap. From here to here, more gap. From here to here, more gap. Wherever the electron beams is very closer, in that position, I am keeping catcher output cavity. That one is mentioned in this paragraph. The catcher output cavity is located near the point where the bunching is greatest. Next, this output catcher cavity is tuned to same resonant frequency as the input frequency. Overall, the wave is modulating. Overall, the wave is modulating with respect to the time. So you have to write, this is the answer for which one? This is two-way cavity klystron. Two-way cavity klystron. Rough diagram we will see because diagram is important for examination point of view. Okay, rough diagram we will see now. How to draw rough diagram. It will be practice for you. Is it? Mm. Mm. Exam. I board the space. Mm. Raja.
Still,
First,
buncher cavity వేసుకుంటే
two
అయిపోతుంది.
buncher cavity, catcher cavity వేసుకోండి.
Mm.
Mm. Two cavities you draw. One is buncher cavity, another one is catcher cavity. Just this is not neat. Just I am drawing one rough diagram. All of it draw the diagram. One side is cathode. What you have in one side? One side is cathode. Another side, anode. To this one, what we are doing? Not anode, collector. Under side is collector. How many cavities? Two cavities. One side it will not work. One side we have cathode, another side is collector. This collector and cathode is connected to negative supply and positive supply. Negative supply and positive supply. In this, keep differentiation that electrons are very closer or far away. Electrons is very closely connected or far away is connected. And draw a sine wave after this. Only one part, sine wave part, positive half cycle, another one is negative half cycle. After the diagram, positive half cycle. In the diagram, mention drift space region also with two grids. Positive electrons is accelerating or deaccelerating? Electrons is accelerating in the positive. What about in negative? Electrons is accelerated or deaccelerated? For the negative, electrons is deaccelerated. For negative, electrons is deaccelerated of electrons. For the negative one. What about density, current, EMF relation after diagram? First you complete diagram. But, relation between density, current, and EMF. If density decreases, current decreases, and EMF increases. If EMF is increases, electrons is accelerated or deaccelerated? Electrons is accelerated. Electrons is accelerated. Next. Density increase of the deaccelerated. Next, density decreasing, current decreasing, EMF increasing. Then what is the status of electrons? Electrons is accelerated. This is accelerated electrons. Practice this one for the examination point of view, where in simply, easily you can explain this one. Next one is magnetron. After this comes to magnetron, which is page number 101. Come to page number 101. Magnetron. This is also one of the important question. See the back side here, essay question for model questions. Essay, what is mentioned here? Discuss in detail with a neat diagram of about two-way cavity crystallon. Important question. This can come in short. Next, magnetron. Just first, we'll see the description of the diagram of the magnetron. What we are observing in this one bigger circle. Inside we have smaller circle with resonators, with tubes, interconnect, tube-like structure connection. Okay, na? Here, the outer circle is called what? The inner circle is called what? Here, the outer circle is anode. The final circle, total bigger circle is here. Na? Draw the diagram in book. Draw this, keep heading and draw the diagram. That complete total outer circle. The outer circle is what? Anode. The outer circle is anode. The inner circle, internal, we have one circle. This inner circle is called as cathode. The inner circle is cathode. In between, we have cavities. In between, we have cavity. The cavity connection, I'm calling this as a slot. Cavity connection is called as slot. There is a space inside the dots. Where? Inside the cathode. The dots inside the cathode is called as what? Interaction space. That is interaction. Okay, this phase. After that is interaction space. So not this one. And this one is interaction space between the resonator cavities and cathode. Just a small correction. Which is interaction space, the space between the resonate cavities and cathode. In between that space is called interaction space. To this one, I am applying DC voltage as well as magnetic field. To this diagram or to this circuit, what I am applying? Applying DC voltage plus also applying magnetic field. Magnetic field. I am applying magnetic field. Field apply just దీనికి outer connection లేదు ఇందులో. Outer connection is not shown in this. The space between these two cavities. Here we are taking 180 degrees pi mode. Okay, so last line is given. The phase change between the two adjacent cavities is 180 degrees. The phase change between the two adjacent cavities is 180 degrees. The space change between the two cavities is 180 degrees. Now we will see the description. Understood the diagram? So the first paragraph is completely about the description of the diagram. What is given here? Magnetron is a high power microwave oscillator. It contains a cathode, anode with many resonant cavities. The basic structure of cylindrical magnetron consists of a anode with number of resonators. Resonators means these cavities with caps. We have now that one we will treat as the resonators. All this combination is called resonators. Anode now arranged in a cylindrical fashion, in a cylindrical cathode. The space between the anode and cathode is called interaction space. The space, whatever the space we are treating, that is called interaction space. To this one, I am applying magnetic field. We said what is written? A permanent magnet is used to provide a strong magnetic field B which is perpendicular to the tube, but in this not shown how we are applying magnetic field. External diagram is not shown. Next, a high DC voltage is given to the anode. DC voltage ne anode ka apply chesam. Two cavity, the cavities represents N coupled resonators. Here, how many resonators we have? 1, 2, 3, 4, 5, 6, 7. 3, 6, 7. 7 resonator we have. Like that, we also have N coupled resonators is also possible. Next, thus a magnetron oscillator is the pi mode, and the angle between the two cavities is 180 degrees or pi radians. 180 degrees or pi radians. This paragraph. Next paragraph. Description of the diagram is over. Next, when DC voltage, I said we are applying DC voltage as well as magnetic field both. When DC voltage and magnetic field both are adjusted properly, electron will flow in cycloidal path. First, see the diagram, then we will see the description. Suppose no magnetic field is passed, then it is going in straight direction. Just see here. The path is, it is going in straight. When it is moving in the absence of magnetic field. Magnetic field apply cheyaledu. When magnetic field is not applied, it is like passing in straight direction. Suppose this magnetic field is greater than critical magnetic field. Here I am choosing one term called critical value or critical magnetic field. At that time, if magnetic field is greater than critical magnetic field, it is taking cycloid path like this. Actually, again, it will come to the original position, but it is not coming to the original position. That is moved in cycloidal direction. It is moved in cycloidal direction. Okay. Next, if the two magnetic fields are equal, if magnetic field and critical magnetic field both are equal, what happening? It is and coming to its original position. If magnetic field is too greater, this one is difference in the field. This is B greater than BC. This is also B greater than BC. But the variation of magnetic field is different. At that time, what happening? It is not traveling for long distance. For smaller distance only, it is path touching to the cathode. Now we will see this 4 diagrams description is given in the above paragraph. Now see what is given based on the diagram. In the absence of magnetic field. In the absence of magnetic field, electrons travel straight from cathode to anode. As B is increased, electron trajectory gets curved and it is going cycloidal path and coming back to the original position when B is greater than or greater than or equal to BC. Where what is BC? Is critical magnetic field. When B equal to BC, it is coming to the original path. But after traveling a large distance, there is a difference in the diagram. So you have to explain this one. Next, you have to write the voltage equation. If essay question, you will get a simple description of the diagram, these waveforms. Next, the derivation part. In the derivation part, we will start. What is E? E is the electric field. B is the magnetic field. And the force is acting on the electron. Force is applied. Here, B is not magnetic field. B is magnetic flux density. Okay, B is magnetic flux density. Both are right angle to each other. Both are right angle to each other. Here we are considering V is the velocity of the light. First, what we have F equal to MA. A is written as dV by dt. F equal to MA. This MA is writing as minus E. E plus V into B. E plus V into B. Electric field into velocity into magnetic flux density. Okay. In the first unit, I don't know who attended. In the first unit, we discussed polar coordinates. Rectangular waveguide, cylindrical waveguide. So those statements I think here based on the first unit, we have to learn directly from 11.2.
System.
11.2, 11.3, 11.4. These equations you have to learn directly. In the next session, I will discuss first unit. Huh? There, you will observe this. Okay. What are the cylindrical coordinates we have here? R by Z. What is the first equation? D square R by dt square minus R times of d phi by dt whole square equal to minus E by M ER Bz of R d phi by dt minus B phi times of dz by dt. So directly you remember these three equations. You have to write these three equations. Based on these three equations only we will get. Next, what is the frequency value? Omega equal 2 pi f in general. Okay, here angular frequency omega c is writing. Omega c equal to E by M times of B. What is omega c equal to E by M times of B? And next, here I am considering field as Bz. Based on these points, we will see the derivation as the next step. From 11.6, 11.6 from where? 11.2 is written as it is. Just check 11.6 from where you got 11.6 equation. 11.3. What is 11.3 equation? 1 by R d by dt R square times of d phi by dt equal to E by M Bz dr by dt. So here what I am doing, I am taking E phi and Br as 0. 11.3 ఉందా 11.3 లో E phi Br ని 0 పెట్టేసి ఈ మైనస్ ఆఫ్ మైనస్ ఏమవుతుంది ప్లస్ అవుతుంది minus of minus plus. This one is written in 11.6. Then 11.6 లో రాసాం. నెక్స్ట్ స్టెప్ ఏం చేసాం క్రాస్ మల్టిప్లై ఆర్ ఆర్ ఎల్హెచ్ఎస్ లో ఉంది కదా 1 by r. దట్ ఈస్ బ్రాట్ టు ఆర్హెచ్ఎస్. 1 by r ఉందా ఈ 1 by r టర్మ్ ఏమవుతుంది ఇట్ వచ్చేసి దట్ ఈస్ ఆర్. సో d by dt of r square d phi by dt equal to E by M Bz R dr by dt. But I am treating R d by dt equal to 1 by 2 times of d by dt of R square. This is direct step. I am considering let R d by dt is what I am choosing 1 by 2 times of d by dt of R square. Now substitute this one in 11.7. This EM by BZ ఉందా ఇందులో EM by BZ ని ఒమేగా సి అనుకుంటున్నాను చూడండమ్మా 11.7 లో EM by BZ ఉందా treat EM by BZ as omega c. R dr by dt ప్లేస్ లో ఏం పెడుతున్నాను 1 by 2 d by dt of R square. After substituting these two, which equation we are getting? We are getting 11.9 equation. We are getting 11.9. Now, we have to integrate 11.9. After integration, so differentiation terms we are neglecting here. D by dt, I am writing only R square d phi by dt from 11.9 term. 11.9 inch. R square d phi by dt plus 1 by 2. This d by dt term, integrate after integration. 1 by 2 omega c R square, we will get one constant K. One constant K. After that, check substituting R equal to X. ఏం పెడుతున్నాను R ప్లస్ లో X పెట్టాను అప్పుడు ఏ ఈక్వేషన్ ఏమొస్తుంది X స్క్వేర్ d5 by dt ప్లస్ 1 is equal to 1 by 2 omega c X square plus K వస్తుంది వచ్చిందా in that substitute d5 by dt equal to 0. Substitute d5 by dt equal to 0. So what we will get? Only RHS term we will get. Only RHS term d5 by dt. If we substitute 0, we will get K equal to minus 1 by 2 omega c X square. We will get K term. This K term I am substituting in equation 11.10. Cross check. K value వచ్చిందా? This one I am substituting in 11.10. What is the equation LHS we have? R square d5 by dt. LHS term is as it is. In RHS term, 1/2 omega c x square. In place of k, I'm substituting minus 1/2 omega c x square. Make 1/2 omega c common. Which one we have to make common? 1/2 omega c common here. Next, what is left? Before that, r square ni rearranging the term. R square ఏం చేస్తున్నాం? క్యాన్సిల్ అవుతుంది. LHS లో r square, RHS లో r square పోయినప్పుడు మనకు సెకండ్ టర్మ్ లో వాట్ విల్ గెట్ x square by r square వస్తుంది. ఇక్కడ LHS లో కూడా r square ఉంది. కామన్ చేశాక you make common 1/2 omega c r square make common, you will get 1 minus x square by r square. Then you cancel it. R square d5 by dt. This LHS and RHS is cancelled. And finally, what we got? d5 by dt equal to 1/t omega c 1 minus x square by r square. Next, electric field, kinetic energy equation తీసుకుంటున్నాము. That one we had half mv square equal to ev kada. And then from that velocity v square equal to 2evm తీసుకుంటున్నాను. Next, how we got 11.12? 11.12. Here you write beside before 11.12. Actual equation is 2ev0, 2 times of ev0 by m. M equal to y square plus y square plus d5. Okay. In this, okay. This is written using polar coordinates. Okay. Polar coordinates batti equation rasestunam, velocity equation. After that, we will substitute that one. What is the equation we have? V square equal to 2ev by m equal to dr by dt whole square plus r times of d5 by dt. ఇందులో dr by dt place లో 0 పెట్టండి కింద. నెక్స్ట్ స్టెప్ చూడండి. ఇన్ ద నెక్స్ట్ స్టెప్ ప్లేస్ dr by dt place లో ఏం పెట్టాలి? 0 పెట్టండి. dr by dt place లో 0 పెట్టండి. ఇన్ ప్లేస్ ఆఫ్ r సబ్స్టిట్యూట్ y. r ప్లేస్ లో ఏం సబ్స్టిట్యూట్ చేయాలి? y సబ్స్టిట్యూట్ చేయాలి. ఇప్పుడు ఈక్వేషన్ ఏమైతే చెప్పండి. ఆ ఈక్వేషన్ మీకు ఎక్కడ రాస్తారంటే 11.4 లో రాస్తారు. 11.2 నుంచి ఎక్కడికి వస్తుంది? 11.4 కి వచ్చేసింది ఈక్వేషన్. అది నెక్స్ట్ ముందు రావాలి యాక్చువల్ స్టెప్. 11.4 లో ఏమొచ్చింది? 11.4 చూడండి. ఇన్ ప్లేస్ ఆఫ్ dr by dt, dr by dt టర్మ్ ఇస్ 0. మనకి LHS లో ఏముంది? 2ev by m. In place of v, I'm keeping v0. dr by dt term is 0. In place of r, I'm keeping y. Y ki square ఉంది కదా, y square అవుతుంది d5 by dt whole square. From 11.2 నుంచి 11.4.
ఇక్కడ v square equals to 2ev by m instead of v square polar equation.
Polar coordinated equation, cylindrical coordinates
v square కి మాత్రం
v square కి
2ev మనం ఇక్కడ రాసుకున్నాం.
LHS term brought it down as it is. In RHS term, dr by dt equal to 0. In place of r, y is substituted. Y square d5 by dt. This 11.3 ni 11.11 ని కంపేర్ చేయండి అమ్మా. 11.3 ని 11.13 అది 11.13 ఈక్వేషన్ నంబర్. 11.13, 11.11 చూడండి ఈక్వేషన్స్, 2 ఈక్వేషన్స్. d5 by dt 1/2 omega c 1 minus x square by y square. In place of r, y is substituted. 11.11 లో r place లో y substitute చేస్తే 11. ఏది వస్తుంది? 13 వస్తుంది. We will see again overview complete after completing. To 11, so final గా 11.11 నుంచి 12, 13, 14 రాసేస్తాం. 11.12 నుంచి 11.4 రాసాము. అవునా? 11.12 నుంచి ఏదొచ్చింది? 11.14. 11.11 నుంచి 11.13. We brought two equations. After that, we will sit down. Substituting 11.13 and 11.14, we get which equation? 13 లో మనకి d5/dt వచ్చిందా? 13 లో ఏమొచ్చింది? d5/dt. That is substituted in 14. 13 లో we got d5/dt value. That is substituted in 14. RHS as it is. Square ఇక్కడ LHS కి వచ్చింది. So we got 11.15. Based on this, critical magnetic field is calculated. Based on this, critical magnetic field is calculated, and directly here, direct equation. What is critical magnetic field? 8 me square EB naught by m v square E square 1 minus x square by y square whole square. డైరెక్ట్ ఎట్లా వచ్చిందంటే నేను ఒక షార్ట్ హింట్ చెప్తాను, మీరు ట్రై చేయండి. దట్ ఈస్ హోంవర్క్. హియర్ ఒమేగా సి ప్లేస్ లో, ఇన్ ప్లేస్ ఆఫ్ ఒమేగా సి సబ్స్టిట్యూటెడ్ ఈబిసి బై ఎం. మనకు స్టార్టింగ్ లో వచ్చింది చూడండి ఈక్వేషన్, ఈబిజెడ్ ఆర్ ఈబిసి. ఎక్కడ ఉంది చూడండి స్టార్టింగ్ లో ఫస్ట్ ప్లేస్ లో. ఎక్కడ ఒమేగా సి ఈబి బై ఎం కదా. ఇన్ ప్లేస్ ఆఫ్ బి లో బిసి పెట్టి పైన 11.15 కంప్లీట్ గా సింప్లిఫై చేసుకొని వస్తే ఏది వస్తుంది? 11.16 వస్తుంది. You try this into the class. Next, BC square we got from that writing BC. From that writing BC and finally writing voltage. Hall cutoff voltage final. Hall cutoff voltage. But in one year question paper, they asked to explain only about the working principle of. See here we have two types of questions. Just check backside. Working, explain the working of magnetron oscillator. అంటే no need of writing Hall cutoff voltage. ఇక్కడ రెండు క్వశ్చన్స్ ఉన్నాయి చూడండి. ఎగ్జామ్ లో మాగ్నెట్రాన్ అడుగుతారు మాక్సిమం.
డిస్క్రిప్షన్
బొమ్మ గీసి ఎక్స్ప్లెయిన్ చేస్తే చాలు. సో 11.2. 11.2 is working of magnetron. Next, derive expression for the Hall cutoff magnetic field and Hall cutoff equation. This is which is in that only, but derivation part. So magnetron means only diagrams, explanations. ఏదమ్మా ఇక్కడ నుంచి రాయాలి. Hall cutoff అంటే derivation రాయాలి. Magnetron. Just go through this topic once again. Then we will start the next one. What is the function of magnetron in general? What you understood? Magnetron. Anode, cathode, resonant cavities, interspace region. Resonators are connected with 180 degrees phase adjacent each. And number of resonant. Here up to 11 only we have. Up to 7 here. 7 up to N facilities also available. Up to N facilities also available. To this one we are applying magnetic field as well as DC voltage. Magnetic field apply చేస్తున్నాము, DC voltage. And there is electric field and both magnetic field are perpendicular, right angle లో ఉంటుంది. And here electrons is flowing in which direction? Cycloidal path. It is important. Electrons are flowing in cycloidal path. Circle shape. Not complete circle. this, whatever we have, cycloidal path. Next, draw this 11.2 diagram, description of the diagram. If you write all these things, magnetron is covered. And next, what we discussed, next is Hall cutoff, magnetic field and Hall cutoff voltage equation, frequency formula, and three polar cylindrical coordinates in terms of R, phi, and Z. After writing this, what we did, we took frequency equal to EB by M. And here magnetic field chosen as B equal to BZ. Based on that, what we did, writing 11.3 equation. From 11.3 only, now we got 11.6. In 11.3, we are keeping E5 and 0, B are 0. Rendu 0 పెడుతున్నాం. Next ఏం వస్తుంది? BZ dr by dt వస్తుంది. BZ dr by dt. Better. And after simplification, we will get final critical field. After complete derivation, we will get the critical field. B, more. The magnetic field is more. Here, a little bit more. Actually, not same. Not mentioned. Small correction in this. B greater than BC. B greater than B greater than BC. This is only B greater than BC. Double. This is about which one? Magnetron and Hall cutoff voltage. So just come to block 5. We completed block 5. What are the things we discussed in block 5? Two cavity klystron, magnetron, Hall cutoff voltage. In the last class, traveling wave tube is also completed. Next, now we will see antennas, short answer questions. Thus, come to block 7. Block 7 lo essay questions అయిపోయినాయి. What are the essay questions we discussed from block 7 లో? Antenna fundamentals lo what we discussed? Which type of questions we can expect as an essay from these?
Fundamentals.
First antenna fundamentals. And page number 142. Derivation. Good. Next. And block 7. What are the things? Just we will see in 142 page, full forms of the different frequencies. VLV, ULV ఉంది చూడండి. Before discussing essay questions, just we will see the different types of bands available and its frequency and its applications. Antennas. Already we discussed VLF, VH, very high frequency, VHF. Somewhere we use the term VHF. Helical antenna lo cheppan, parabolic reflector lo VHF. Here what we have? What is VLF? Very low frequency. Just check the list which is useful for further topics. VELF means extremely low frequency. It's means very low frequency. It is in terms of only hertz. It is in terms of only hertz. What is the frequency here? 3 to 30 hertz. Next, SLF, super low frequency. This super low frequency is from 30 hertz to 300 hertz. Next, ultra low frequency. Ultra low frequency is from 300 hertz to 3 kilohertz. Just full forms is useful for further topics. Next, very low frequency. Very low frequencies from where? 3 kilohertz to 30 kilohertz. Low frequency, 30 kilohertz to 300 kilohertz. Mid frequency, 300 kilohertz నుంచి 3 megahertz వస్తుంది. Next 3 megahertz to 30 megahertz, 30 megahertz to 300, 300 megahertz to 3 gigahertz, 3 to so what is this feature of 3 to 30 gigahertz? So anyone? Super high frequency లో అన్ని కవర్ అవుతున్నాయి చూడండి. In super high frequency, from where the first frequency started? 3 నుంచి స్టార్ట్ అయింది కదా. ఎండింగ్ ఫ్రీక్వెన్సీ ఫర్ అల్ట్రా హై ఫ్రీక్వెన్సీ 3 gigahertz. It is more than 3 gigahertz up to 30 gigahertz. So whatever present we are using in radars, satellites, microwave communication. In present cases, we are using which one? Super high frequency, HSF uses. Applications, which one is used for which one? Ultra high frequencies for TV, LAN, cellular, GPS. What is LAN here term? Somewhere we discussed when, I don't know, LAN. Yesterday, local area network. Yesterday topic, LAN. What is a local area network? What is the meaning of local area network? Some region, up to some region. Up to some bandwidth world area network. Complete worldwide. MAN, metropolitan area network. Small region is LAN. Next is MAN. Next region is WAN. So in those, which frequency we are using? Ultra high frequency, UHF. Ultra high frequency is used. Next is very high frequency. In very high frequency, where we are using TV, FM broadcast. Next is shortwave broadcast. AM broadcast. What is beacons? What is beacons? You hear the term beacons? You hear submarines? Submarines means
insurgency. Submarines which one can go inside underwater.
What is beacons? It is like one of the tool like radar, satellite used for communication only. It is used for communication to mention a specific location. It is used to detect a specific designed to attract attention to a specific location. And this is about different frequencies. And next what we have? Bands, different bands. L, S, C, X, KU, K, KA. Different band of frequencies. In band diagram ఉంటుంది. Next page లో చూడండి. Different frequencies, transmission bands. It is not there. Not there in this. It's not mentioned. These are the what? Band frequencies. Large S, C, X, K, U, K, and K. This is a just introduction part. Now, which one we will discuss is? Now this gain of the antenna. 15.6 cm. 15.6, 15.7, 15.5. Can expect as a short question. 15.6, 15.7, 15.8. These three now we will see. First we will see 15.7 antenna impedance. Next come to, in online only we discussed antenna theorem. Antenna theorem is complied online and offline both. Next in this antenna, what is this topic? Gain of the antenna, 15.6. Come to 15.6. Gain of the antenna, children. This is previous year question short. Previous year question so short. What is the gain of the antenna formula? Gain of the antenna is the ratio of the
intensity of antenna under test by maximum radiation intensity from the reference antenna with the same power input.
Gain of the antenna is the maximum radiation intensity of antenna under test by maximum radiation intensity from reference antenna. Under test condition, from where we are taking reference. While doing some experiments using reference values only, we will decide whether it is correct or not. Is it? Reference value. So
the same power input.
With same power input. For both the cases, input is same. We are testing based on the reference. The numerator is tested one. Denominator is reference one. That is called as the here gain of the antenna. This gain of the antenna, the reference antenna can be of any type. But often the reference is taken as 1/2 of the wavelength of the antenna. Here we are taking as a reference as the 1/2 times of the wavelength of the antenna is lambda. Is it? Okay, half of the wavelength we are taking as a reference. And we are using one formula G equal to KD. What is K? Here K is the efficiency. What is K, ma? K is efficiency. What is D here? Directivity. D is directivity. The ratio of the gain to the directivity antenna is the efficiency factor. Actually, what we have? G equal to KD. Now, efficiency factor K was the gain by directivity. G by D. K equal to G by D. That is giving the definition of efficiency factor. K equal to G by D. The ratio of the gain to the directivity is known as efficiency factor, which K equal to G by 2. The K value is lies between 0 to 1. K value is lies between 0 to 1. Suppose if it is 1 means we are using lossless medium. Directivity is in which medium? Lossless medium. If suppose K is less than 1, losses are present. Some fluctuations, losses is there. If K is less than 1 means we are getting losses. If K equal to 1 means there is no loss. What is the meaning of no loss means? Whatever is produced across input, it is reaching to the output. That is called the gain of the antenna. Next here we have in the continuation efficiency. Here we have 3 definitions in this. Is it? Efficiency neta is equal to power. Which power? Ratio of the radiated power by total input power. What is radiated power we are treating here? Radiated power is P of R. Efficiency definition. Radiated power is P of R and input power is P of in. The ratio of radiated power by input power is called as efficiency. Next, one more definition we have in this. What is another definition? Radiation resistance RA. Radiation resistance. See here, radiation resistance is denoted with RA. Suppose I want to take RA, 2 times of radiated power cross multiplication. 2 times of radiated power by current I square. By current I square. Based on this, the definition is given. See the definition? The radiation resistance of an antenna is equal to the resistance which would dissipate same amount of the power. The amount of power it is dissipating when the current is resistance equal to the input current. When the resistive current is equal to the input current. So definition, how you will write 2 types of current. Resistive current is equal to input power with radiated power. What is PR? PR is radiated power. That is called as resistance of the radiation resistance. I will repeat once again. Here we are taking 2 currents. What are the 2 currents we are taking? Input current, current in that resistance. current in the resistance. When both are equal, at that time some power is generated. Using that one, we are defining radiative resistance RA. Definition మీకు formula ని బట్టి definition రాయాలి. ఇక్కడ formula ఏంటి? What is the formula? Radiated power formula. Radiated power PR equal to current I square by 2 times of RA. So, what is the definition of RA? When two currents, for that I am writing I square. Input current and current across the resistance. I square in the input current, current across the resistance with power radiated equal to radiation resistance. This is the definition. What is I here? I is the peak value of the current. I is the peak value of the current. So if you get short question, these definitions you have to write. What you will get question? Gain of the antenna. Maybe previous years in assignment also this question is giving gain of the antenna. 5 marks question. Another question is there from this antenna impedance. In general, the output of the one circuit, I am connecting to the input to the other circuit. The output of one circuit is connected to the input of other circuit. Whatever the maximum current is there in the first circuit, that is delivered to the second circuit. That is given as a first paragraph. The output of one circuit is connected as the input to the second circuit. Whatever the power is given in the first circuit, the same power is delivered to the another circuit. Now just see here definition what is given. Maximum power transfer from one circuit to another is the output impedance of one circuit is equal to the input impedance of the following circuit. Whatever the output impedance we have, that is connected as a input impedance to the another circuit. Same conditions is hold good for the even power case also. In terms of power also, we will write same. The power of one's output power of one circuit is goes as the input power to the other circuit. Output power of one is equal to input power of other. For efficient transfer of power, the input impedance of the antenna must be equal to the input impedance of the transmission line. Line channel is there na? From input to output. In the middle, what we have? Transmission line. So the output of the first has to match with the transmission line. Then only the other end of transmission line will match with the second end. That sentence is given here. See, the input impedance of the antenna must be almost equal to the impedance of the transmission line. That is used for connecting the transmitter output to the receiver side. So we have one side transmission, receiver. Transmission other end has to match with transmission line. The other end of the transmission line has to match with receiver. Transmission is receiver transmitting. So that is given in the first. Just go through the first paragraph once again. Antenna impedance. Same condition holds even in the case of power. In the second paragraph, voltage is minimum. Conditions you just write. Voltage is minimum. Current is maximum. Voltage is minimum. Current is maximum. Then impedance Z is minimum. Then impedance Z is minimum. Similarly, you tell another condition.
Voltage is maximum. The current is minimum. The impedance is maximum.
Voltage is
maximum.
Voltage is maximum.
Current is minimum.
Current is minimum.
The impedance is maximum.
Impedance is maximum. Impedance is maximum. In this, we have like bubble shape. Is it? Here, two ends impedance is maximum. In these two ends, impedance is maximum. If two ends impedance is maximum, means what is the status of voltage and current? Voltage is maximum, current is minimum. Across here, across the end point, down point.
Impedance is minimum.
Impedance is minimum means current is maximum, voltage is minimum. That's it, this diagram. Understood? Based, so what is written, given for the first paragraph, what is given in the second paragraph for the topic antenna impedance. First paragraph, what has to cover in the second paragraph?
The first paragraph, they given is the one circuit to the power.
How to connect from one circuit to the other.
The power also it will into one circuit to the end circuit without losing any
Loss.
loss.
Without losing any loss.
And the second one,
In second paragraph,
if that voltage is minimum, that current maximum, that the impedance is
also.
minimum.
So voltage and impedance is directly variations. And based on diagram, you have to show that where is maximum impedance, where is minimum impedance. So this is about this one. This, okay. Next, another one can be treated as short. In this directivity D. Check which page number it is. Directivity D. Open 150. I will check if any other short questions when I come from this. Helical antenna is over. Parabolic reflector is also over. Essay questions. Here, how many essay questions we can expect from this? Who attended last class?
Antenna theorem.
Antenna theorem.
And,
Essay question. From unit 15. From unit 16.
and sometimes antenna fundamental things will ask.
Previous, as per previous, just I said. Next from unit 16, what are the things? Helical antenna. Unit 17. So these are, you only said previous yearly repeated questions. Antennas odloddu. Compared to previous, only theoretical parabolic reflector. Short gain, efficiency and directivity. What is the directivity? Which one? Maybe. Fifth, ఇప్పుడు ఏది చూస్తున్నాం మనం డైరెక్టివిటీ. First unit 15 లో first question చూడడమా, mention the microwave bands. Just now microwave bands students, which first cover for microwave bands అంటే ఏది రాయాలి? Microwave bands. ఎక్కడుంది చెప్పండి, మీరే చెప్పాలి. Frequencies. So for which question, which answer కూడా ఇంపార్టెంటే కదా, చూసుకోవాలి వెనకాల మోడల్ క్వశ్చన్.
స్టార్టింగ్ నుంచి మొత్తం ఎండింగ్ వరకు రావాలి.
ఇక్కడ వరకు రాస్తే అదే ఆన్సర్. వాట్ ఇస్ ద క్వశ్చన్ ఈస్ గివెన్ ఇన్ ద టెక్స్ట్ బుక్? మెన్షన్ ద మైక్రోవేవ్ బ్యాండ్స్. మైక్రోవేవ్ బ్యాండ్స్ అంటే లిస్ట్ అప్లికేషన్స్ where we are using those applications. Frequency range, applications, and which type of bands. Others. Now you see directivity. Directivity short answer question. Gain is short answer question. Antenna impedance is short answer, which repeated in previous years. Not I am preparing. Just don't ask again that madam you said not coming these questions. Just previous year these questions are covered. Next directivity D.
Beam width page number 149.
14.
This beam width simple question, separate question mark inside. Beam
Width, okay. Page number
149.
149.
It's here. Beam width, it is a
Beam width.
radiation pattern. Radiation pattern.
Radiation pattern beam width.
Yeah, beam width.
Width. Page number ఎంత
149.
Page number 149. Beam width.
Small.
Radiation pattern. Just I will give overview as you asked. Huh? I will give explain overview. Questions. ఒకసారి అమ్మాయి అడిగిందిగా 149 పేజ్ ఓపెన్ చేయండి. Just I will tell in short form how to refer for the examination point of view. Page number 149. See, radiation patterns, we discussed this one in parabolic reflector. Did you remember the diagram?
Yes, ma'am.
In parabolic reflector, how we have like this with small here lobes. Page number parabolic reflector answer. Okay. 167. 167 parabolic antenna. Two modes is possible, normal mode and in axial mode. Axial mode, we have major lobes, minor lobes. Based on that, you observe the lobes here. How the radiation pattern forming ikkada. Based on 167 page, now you observe 149 page lobes. The bigger one is major lobe, main lobe. The bigger one is major lobe. Again, you have side beside smaller ones. Those are side lobes. And here you have few more backside lobes is forming. This is called back lobes, side lobes, main lobes. Next, based on this half power bandwidth, HPWB full form, half power bandwidth, the angles is mentioned. And the first, whatever the direction we are choosing two sides, that one is what? First null. This one. Next, two more slant angles is given. Like actual, the diagram is like this. This is main lobe. Beside you have side lobes. Beside you have back side. Back lobes you have. Once two sides slant lines is there. This is first null. If I choose similar, this is second null. This. First null, second null, main lobe. What is HPWB? Of power bandwidth. To this, we are taking angles values. Mention this one if you get this answer. Description of this diagram you have to write with the formula. Average by overall maximum value. Average value by maximum value. What is HPW? Of power bandwidth. What is FNBW? First null bandwidth. First null bandwidth value is 74 degrees. Off power bandwidth value is 40 degrees. 40 degrees. Beam width adugutidi raala answer. And now next come to which one? Directivity D. Is this clear, ma diagram? In this, if you get question, in this, just include the formula. What is normalized field pattern? After writing the description of the diagram, what is normalized field pattern? E theta equal to theta comma phi. Where E theta comma phi equal to 1 by root 2 equals 0.7015. Mention this one is enough. If they ask question, beam bandwidth. And next come to the directivity. The antenna. Page number. What is directivity? Maximum power by average power. It is a ratio of the maximum power by the average power. What is maximum directivity? Is referred as the, it is also called as the directivity D. It is also called as directivity D. It is a measure of ability of antenna to concentrate the radiated power in a given direction, whether the power is radiating or not in the particular direction. Suppose I want to keep like TV dishes, antennas, Airtel, parabolic reflector. Parabolic reflector topic, who listen, ma? In that parabolic reflector is a dish. I said, same way to this, in the particular direction, whether it is transmitting or not, is the directivity. The maximum directivity is referred as a measure of ability of antenna to concentrate the radiated power in the given direction, whether the in the particular direction power is going or not. That is called as directivity. Here we have power. Maximum power density is represented with P of theta comma phi with the average value. What is average value? Same P of theta comma phi of maximum by P of theta comma phi of average. With small steps we have. What is the ratio of maximum power to the average power over a sphere far field of antennas? If we want to send for longer distances, okay, if we want to send for the longer distances, actual what happens here, I don't know whether you remembered or not, parabolic reflector, I said we have in the middle focus point. Okay, what this radiation will do, it will scan. While scanning, it will move like this in sphere shape. Scanning ఎట్లా చేస్తుంది? ఇప్పుడు focus point ఇక్కడ ఉంది, radiation. It is whether మనం ఏమంటే signals is there or not. So it will overall, it will scan. That mentioned here, sphere, over a sphere. For antenna, for the far field of antennas. Okay. If directivity is dimensionless, then what is ratio? Ratio is greater than or equal to 1. Small derivation part is given. Just go through the derivation. What are the steps is given in the derivation? Average power density formula is given. That one is substituted in the directivity formula. Average power density formula is given. And that is substituted where? In the directivity formula and simplified. Just check the steps. This is substituted and finally brought one equation and equal to 2. 4 pi by 2 pi equal to 2 and just go through this one. Can make expected short. Just we will recall which one? Parabolic reflector. As few members are new here, already in online mode also we covered. Now you tell any one of you. Only for 5 minutes. Then I will stop. Unit? Just go through and tell me fast. Two diagrams is, one diagram is for transmitter, another diagram is for receiver. Is it? This is the transmitter diagram. This is receiver diagram. Diagrams are the concept. I will show here diagram now. Just check here. We have Airtel like a dish which we will observe on the our houses home, like umbrella shape. This is like we have dish. Here center point, focus point is the center point. Like this with the center point. So here the arrows is inside. This is mistake. Like this. Suppose it is reflecting like this. Hitting and going outside. This is focal point F. This is the point G. Internal arrow hitting and going out. F, G. This is G dash. FG, G dash. If it is incidenting in another point, suppose treat that point as J. FJ, J dash. Another one, similarly, other. Suppose it is hitting here. FK, again it is reflecting back. K dash. Another point, H. F, H, H dash. This is for transmitter side. This all is transmitter and full forms is mentioned. Next, then the next page you have diagram for reflector. Reflector is coming from outside. Outside is coming and falling on the dish. Distance ekkadiki vastundi? Focus point. This one focus to dish, dish to outside. This one is outside to dish, dish to focal point. Draw a diagram. Explanation of the diagram only. Easily can learn this topic. Don't leave. Here's the focal point. A ray is coming from outside. Ray is coming from outside and touching to the focal point. Another rays came to the dish and touching to the focal point. Another ray is coming and touching the focal. Another ray is coming and touching the focal point. So this is for which one? Receiver point. This is the transmission part. And here two types of radiation patterns are forming. The two types of radiation patterns is this one. Normal mode and axial mode you have. Here two types of patterns will form. Normal mode and axial mode. See here, like this, main lobe, secondary lobes. Main lobes and secondary lobes. Go through this topic. Antennas is a scoreable. Don't leave the question, even it is shorter essay from the antennas.